So I'm just going to do a few representative word problems. So I'm just going to show you the picture so I don't have to like explain it. So look, there's a golfer and he hits it off the tee, and there's some information because I don't know golf. So I'm going to draw the picture and then we'll read all about it. So what I have is working backwards. Not working backwards, but whatever. I have 140 yards here. And then I'm going to go this way, and I've got 25 yards. This is not drawn to scale. And this is 125 degrees. So what I have is a golfer hits an errant tee shot that lands in the rough. Here's the rough. A marker in the center of the fairway is 140 yards from the center of the green. While standing on the marker and facing the green, the golfer turns 125 degrees towards his ball. He then paces off 25 yards to his ball. How far is the ball from the center of the green? So I'm trying to find from here to here. So the question is, do you have a completed ratio? No, you do not. But I'm trying to find the side opposite an angle that I have, so I can just use law of cosines. So I can say that this is big A, this is little a, okay, and then this would be big B and little b, not that it matters, and big C and little c. But all I'm looking for is this side. I don't have to complete the triangle. So I know that A squared equals B squared plus C squared minus 2BC times the cosine of A. So I'm going to take this, oops, sorry, I'm not going to do that yet. So I've got A squared equals, and then I've got 25 squared plus 140 squared minus 2 times 25 times 140 times the cosine of 125. And now I can take the square root of both sides. So what I end up with is the square root of, I've got 25 squared, so 25 squared plus 140 squared minus 2 times 25 times 140 times the cosine of 125. Reading over, making sure I entered it right, and I get 155.69. So he is 159, I forgot what I just said, 155.69 yards away from his ball. Or that's, wait a minute, that's how far the ball is from the center of the green. And yes, it is in yards. I had to check. So, let's do another one. We have a boat. So this is San Juan. Okay. And this up here is Barbados. And I know that this is 600 nautical miles. And I'm looking at this little picture right here. So let's push this back a little bit and then look. I have this scenario right here. So I've got a cruise ship that's going from San Juan to Barbados, but there's a storm. And it's supposed to be 600 nautical miles. But he's got to swing out this direction to avoid the tropical storm. So what we have is a cruise ship maintains a speed of 9 knots, which is nautical miles per hour, sailing from San Juan to Barbados, which is a distance of 600 nautical miles. To avoid a tropical storm, the captain will head out of San Juan at a direction of 35 off of a direct heading from Barbados. So he was going 35 due north, but now he's going to swing out 35 degrees. Okay, the captain maintains the 9 knot speed for 5 hours. So he's going 9 nautical miles per hour for 5 hours, which means this distance is now 45 knots. I'm sorry, not 45 knots, 45 nautical miles. Okay, after which time the path to Barbados becomes clear of storms. Through what angle should the captain turn in order to head directly back to Barbados? And then once the turn is made, how long is it going to take before the ship reaches Barbados if the same 9 knot speed is maintained? So what we have is if he keeps going that direction, he's going to miss Barbados completely. So I've got to find out if he's in this direction, how far does he need to swing back? Okay. And then from there, what information do I have to complete this thing? So I don't really care necessarily about that angle. I may have to find it. I don't know. But I do know that I have a side angle side, which means I can find the remaining side, and then I'll have a completed ratio. So that's where I'm going to go towards. So I'm going to say that this side right here, and we'll just call him, what are we going to call him? We will call him C. Okay, so that's side C. So I'm going to find C squared equals A squared plus B squared minus 2AB times the cosine of big C. So I'm looking for this, which is opposite a known angle. So I've got C squared is 45 squared plus 600 squared minus 2 times 45 times 600 times the cosine of 35 degrees. So I don't care what C squared is, care what C is. So I'm going to take the square root of both sides. So I have C equals the square root of, and I got 45 squared plus 600 squared minus 2 times 45 times 600 times the cosine of 35 degrees. And I end up with 563.729. So this side right here is 563.729. Okay. So 563.729 is that. So I now have a completed ratio. Well, I would like to know what this angle is. Okay. So if I want to know what that angle is, well, I've got a completed ratio. And now I can do this ratio of his side to his angle to find that missing angle. But do not fall in the pit of despair, because that is not quite where we want to stop. So I have a sine ratio of the sine of 35 over 563. And it says don't round to the final answer, and then round to one decimal place is needed. So we've got that 729 equals the sine of, we'll say big B. Ooh, no, because that was Barbados. All right, we'll say the sine of big A, not that it matters. The sine of big A over 600. Okay, I assigned that to Barbados. You can't do that. So I'm going to cross multiply. So I have 600 times the sine of 35 is 563.729 times the sine of A. So I'm going to divide both sides by 563.729. And then I'm going to take the arc sine. So the arc sine, of both sides will make that angle measure pop out. So remember, we were supposed to use unrounded values. So I'm going to copy and paste this on my calculator. So I have the arc sine of 600 times the sine of 35 divided by, and then I need to use the unrounded value. So, which is rounded anyway. But we get 3762.426477. So basically 37.624 is what this angle measure is. So he is 36, what did I just say? 624.624 degrees. Well, I need to know how he needs to swing, because right now he's on this path. And I need to get him back over here. So these are supplementary angles. So what degree does he need to swing through to get back onto this path? So I'm going to do 180 minus that answer. And I get 142.4. So that is my final answer. So the degree measure that he needs to swing through is going to be 142.4 degrees. So he was on this path, and now he's going to swing back this direction, 142.4 degrees. He should do it slowly, otherwise his boat will flip. All right, so now what do I have? The second part of this question says, how long is it going to take for him to reach Barbados? So I know he's got to travel 563.729 miles, okay? And I know he's traveling at 9 nautical miles per hour. So if I take that original 563.729, whatever it was, and divide that by 9 nautical miles, we're doing miles per hour. What are we doing? Hang on, stop it. So we're going to go, that is wrong. Hang on, pause the problem. That is not wrong. We're going to go 62.6 hours is what we're going to do. So, that is exciting. So 62.6 is your answer. That just does not sound right, but there you go. So it's going to take us basically 2.5 days to get us where we need to go. So that is that problem. Let's see if there's something more exciting. Ooh, let's look at a femur bone. Okay, so we're going to look at this femur bone. Here's this part of your femur goes into your hip socket, and it allows you to move the top of your leg around. So the Purkinje triangle, located at the proximal end of the femur, has been used to identify the gender of fragmented skeletal remains. So please see the figure. So I'm going to draw this A, B, and C. So looking at that, I have A to B to C. So here's A, B, and C. And so it says, given that AB is 33.8 millimeters, given that AC is 52.9 millimeters, and angle A is 86.6 degrees, I would like to know what the length of BC is. So I know, ignore him. Okay, I know that I need the side length opposite an angle that I have. So we're just going to call him little a since it lines up that way. So I've got little a squared is b squared plus c squared minus 2bc times the cosine of big A. So I've got a squared equals 52.9 squared plus 33.8 squared minus 2 times 52.9 times 33.8 times the cosine of 86.6. And we're going to take that thing's square root. So it got kind of snarky over there at the end. So I will carefully explain what we are entering in our calculator. The square root of 52.9 squared, okay, plus 33.8 squared, minus 2 times 52.9 times 33.8 I said, times the cosine of 86.6 degrees. When I hit that, I get 61.06. So this side length is 61.06 millimeters. So if the average length of that is 59.4 for male and is 53.3 for female, then what should we declare this bone originated from? And so since 6106 is a close approximation to 5904, we're going to declare that this bone fragment is from a male. So you should be able to do the last couple. And that is going to conclude section 9.3.